I will give you some time at the end of the class to ask me any questions that you'd like to ask me that have to do with something beyond the midterm. Well, in the interim, I'm going to be continuing with what we had been doing on last Tuesday and Thursday, which is discussing rational expressions. And specifically, we've been working on solving rational equations. Again, this is not going to be on the midterm. This is chapter 5. The midterm includes chapters 1 through 4. Again, I'll remind you that at 2 o'clock this afternoon, you will be able to access your midterm on Blackboard. It is being given on Blackboard. You have until Thursday evening to complete the test. So you have to pick any time between now, Tuesday afternoon, until Thursday night to do the test. You have to allow yourself 1 hour and 15 minutes. And don't think I'm going to do a half an hour now and I'll do a half an hour or 3/4 an hour later. You have to complete it in one sitting. It is going to be on Blackboard, just like this practice midterm was. It's going to be on Blackboard. If anybody has a problem in terms of doing it in that sometime between now and Thursday night, you've got to let me know. You've got to email me so I can set up something different for you. If you run into a problem with your computer in the middle of the test, you've got to let me know. I can reset a test, but I have to have a valid reason for doing that. I won't, if you should have had, that was the point of giving you the practice midterm. Not only as giving you it as a test because you needed a test, but also so that you can see what the setup and how to work that. Does anybody have a question before I go on? Okay, and if not, I'd like to review this, what we did on rational equations. I'm going to give you 2 problems to try. While you're doing this, I'm going to take your attendance. So I want you to solve these 2 problems. X minus 4 over x plus 9 equals 7 over 6. That's one question. And the other question I'd like you to do is x plus 2 over 8 equals -1 over x minus 7. These are 2 examples of rational equations that are what we call proportions. A single fraction on one side equaling a single fraction on the other side. Okay, I'm going to give you about 5 minutes to try these 2 problems. So let's start with the one on the other side. Again, this is what we call a proportion because we have a single fraction on the left, a single fraction on the right. And we said the easiest way to deal with these proportions is what we call cross multiplying. We take the numerator of the first fraction and multiply it by the denominator of the second fraction and set it equal to the numerator of the second fraction times the denominator of the first. That's why it's called cross, because you sort of make an X across as you do the multiplication. This times this equals this times this. The advantage of that is that you don't have any fractions anymore. Multiplying this out using the distributive property gives me 6x minus 24. On this side, we get 7x plus 63. And now we want to bring the x's to one side and the numbers to the other side. I'll subtract 7x from both sides. That'll give me negative x minus 24 equals 63. And then I'll add 24 to both sides to get the x alone. This will give me negative x equals 87. And of course, I don't want what negative x is, I want what x is, so I'll divide by -1. And my answer comes out to be x equals negative 87. And I think that's what a couple of people showed me that they got. So that is a rational equation. Rational meaning it has fractions, an equation that has fractions in it, and we solved it by cross multiplying. We got a regular, we call linear equation, just a regular equation. So let's see what happens when we try to solve the other equation. So again, this is a one fraction equaling another fraction, a single fraction equaling a single fraction. And again, we're going to try and solve it by cross multiplying. So I'm going to do the x plus 2 times the x minus 7, first numerator times second denominator, equals -1 times 8. Remember, I don't put one over the other, I set them equal. Again, no fractions left, but we still have quite an equation to solve. We have to remove the parentheses here, and here we have to have a binomial times a binomial, so we have to remember that we have to use FOIL to multiply these two binomials. So we do the x times the x, and that gives me x squared. Then we do outer, x times -7 is -7x. Inner is 2 times x, so that's plus 2x. And 2 times -7 is -14. And that equals -1 times 8, which is -8. And if you notice, the type of equation that we have here then is a quadratic equation. We have an x squared. Remember what tells us that what we're dealing with is a quadratic equation is when we see an exponent of 2 on one of our variables. And we know when we have this quadratic equation, we want to get it all equal to 0. So first of all, let's combine the like terms. This gives me x squared. -7x plus 2x is -5x minus 14. And that equals my -8. So to get it equal to 0, I'm going to add 8 to both sides. And that gives me x squared minus 5x. Now set -14 and plus 8 gives me -6 equals 0. And remember, what you have to do in this case is you have to factor. So if I factor these two, this trinomial, I'll get x and x. And since the last term is negative, remember one becomes positive, one becomes negative. We need two numbers that are going to multiply to 6, but when I subtract them, they're going to give me 5. Not when I add them, but when I subtract them, which means it has to be 6 and 1. And since the middle term is negative, it's the 6, which is the larger number that goes with the negative, and the 1 that goes with the positive. And then I said each of these equal to 0. So I get x plus 1 equals 0 and x minus 6 equal to 0. Remember, I separate them. So one answer becomes x equals -1. And the other one gives me x equal to 6. So my two answers turn out to be -1, comma 6, which you can put in these. Don't put them in the regular parentheses, because in regular parentheses, it looks like it's an ordered pair. It looks like it's a point on a graph. You can put it in these curly parentheses, or you could just leave it separate. It's fine. There are two answers. The reason there are two answers is because it is a quadratic. All right. So this is pretty much where we had left off on Thursday. Just want to check my messages. I see there are a few messages here. Good morning. Okay, Partana's here and Shanice is here. Okay. Okay, so I'd like to continue from here. I'm going to erase these now, and I'm going to go on to another type of example. This is an example where we also solve the equation. This is a rational equation as well. Where we actually have a whole number plus a fraction equaling a fraction. That's not a proportion, because we have on this side, on this left side, we happen to have more than just a single equation fraction. If this wouldn't be here, then we could cross multiply. But since we have this one here, we have to deal with this separately. And the method I'm going to show now is actually a method that could be used even if you had a proportion. This method, which we call the common denominator method, is really a method we're sort of familiar with. We just used it before. And it can be used on any fractional equation. What we're going to do is, first of all, I'm going to rewrite this as 1 over 1. In other words, if there are any whole numbers, put them over 1, so it's easy to see what is in the numerator and what is in the denominator. And if you look at it this way, you have two fractions on the left side equaling one fraction on the other side. And what we want to do is find the common denominator of this whole equation. That means both sides. And if you recall, the way we find a common denominator when we have polynomials is we first factor. So obviously I can't factor the 1. And obviously x minus 1, there's nothing to factor here. But the x squared minus x can be factored because there is a common factor of x. So I'm going to rewrite this as x times x minus 1. My x is my common factor. X into x squared is x. X into x is 1. Okay. And if you recall the method that we used in finding the common denominator is we start on the left side with the first fraction. Obviously, its denominator is 1. We circle that. We then go to the second denominator. Now remember, polynomials are units. They go together. So the next denominator I see is x minus 1. And then I go to the other side because it has to be the common denominator of everything. And I see a plain x. Now I don't have a plain x yet, so I've got to circle that. But an x minus 1 has already been circled, so I don't have to circle it again. Now, if I multiply together all those things, which means the 1, the x, and the x minus 1, that's what your LCD is. That's what your common denominator is. Now, obviously, 1 times x is just x. I'm going to take this common denominator, put it over 1, and multiply everything by it. So here I'm putting it over 1, and I'm multiplying everything by it. And of course, I have to distribute this. So you know what I'm going to do? I'm going to write my common denominator in the blue so you can see what I'm distributing. So, and I'm not going to put in this 1 because 1 times x is just x. So it's x times x minus 1 over 1. Here's my common denominator times, remember I'm distributing it, so it's times 1 times 1. Plus, now this is supposed to be in black, I'm sorry. Okay, here's our next one. The x times x minus 1 over 1 times x over x minus 1. And that's going to equal the x times x minus 1 over 1 times 1 over x times x minus 1. Okay. I rewrite, I know it takes a lot of time to rewrite it but if you don't rewrite it, then it turns out that you have a very big jumble. This way, it's a little bit easier to deal with. Okay, and what we're looking for is to see if we can simplify by canceling out anything in the numerator with anything in the denominator. Now, here, there's nothing to cancel out, so all I'm left with is my x times x minus 1 times 1, so it just is 1, just remains x times x minus 1. Over here, the x minus 1 in this numerator cancels out with the x minus 1 in the denominator. And all I'm left with is x times x. Now, obviously, this is x squared, but I'm just showing you what I'm left with. I'll do the multiplications at the next step. Finally, we're over here. And guess what? The x cancels with the x, The x minus 1 cancels with the x minus 1. I'm left with 1 here and 1 here. In other words, everything canceled out. And 1 times 1 just gives me 1. The point of this is that by multiplying by the least common denominator, we saw it before when we had just least common denominators that were just numbers. Anytime you multiply an equation by the LCD of the whole equation, you end up with an equation that doesn't have any fractions. But we still have to solve this equation. So I'm going to remove my parentheses. X times x is x squared. X times negative 1 is negative x. Plus x squared equals 1. And lo and behold, when I put this all together, I have an x squared and an x squared, which is a 2x squared minus x equal 1. And it turns out what I have here is a quadratic equation. Sometimes my equations turn out to be linear. Sometimes they turn out to be quadratic. Now we know when it's quadratic, we have to factor. So I'm going to bring the 1 to the other side. You have to set it equal to 0. So that I end up with 2x squared minus x minus 1 equals 0. And I'm going to go over here to my other side of my board. So I have room. I'm going to continue this over here. I have my 2x squared minus x minus 1 equals 0. I'm going to go to the other side to work on this. Now, we have a leading coefficient here of 2. Unfortunately, it's not a common, it's not a we can't factor out that 2. We have to use the AC method on this because we have a leading coefficient of 2. So I'm going to multiply the 2 times the 1, which will give me negative 2. And that means I'm going to be looking for 2 numbers that are going to multiply. Obviously, one's going to be positive and one's going to be negative because it's a negative 2. And they have to multiply it to 2. It could only be 2 and 1. And since that middle term is negative, it has to be the larger number being the negative and the smaller number being the positive. Then I rewrite this trinomial as 2x squared plus 1x minus 2x minus 1. And we now can use our grouping method. Remember, when you're grouping, you just take the first 2 and find a common factor in that first group. Then you do the same thing in your second group. Now, my first group, where I have a 2x squared plus a 1x, my common factor is just a plain x. And that'll give me 2x times 2x plus 1. In my second group, there is no common factor except it starts with a negative, so my common factor has to be negative 1. And this becomes negative 1 into negative 2x is 2x plus 1. And therefore, my common binomial factor is the 2x plus 1. And the other factor is the x and the minus 1. And now we set each of these equal to 0. So we get 2x plus 1 equals 0 and x minus 1 equal to 0. And this gives me 2x equals negative 1. So one answer is negative 1/2. And here I'm going to add 1 to both sides. So my other answer is x equal 1. And just like in the last example that we had done, we end up with two answers, a -1/2 and a +1. Okay. Now, we have to look at something. Is everybody ready for me? Can I erase what's over here? Okay, so I'm erasing everything that I have here except the original problem and the answers. Here was our original problem. And my two answers were x equal -1/2 and x equals 1. And I want to show you what would happen if we tried to check. And specifically, I'm going to try first checking when x equals 1. That's an easier one to check, so I'm going to try that one first. I just want to mention that you could always use your calculator to check. But let me show you what happens when I try to check with x equal to 1. That means I'm going to replace the x in my original equation with 1. So I'll get 1 plus 1 over 1 minus 1 equals 1 over 1 squared minus 1. And if I simplify this, I get 1 plus 1 over 0 equals 1. Well, 1 squared is also 1, and 1 minus 1 is 0. And something very strange has happened here. When I tried to check it, one of my denominators, sometimes more, in this case it actually was 2, but one or more denominator turned out to be 0. Now we know that you can never have a 0 in the denominator. Any answer that would make this happen is not allowed. This is not a good answer. We've got to throw out this answer x equal 1. It's what's called an extraneous root. The word extraneous means something that's extra, that's no good. If something's extraneous, it's something that popped up, but we don't want it. We did all the right work. It wasn't that I did the work wrong, but as a result of working it, I came out with an answer that doesn't make sense. So right away, I have to throw out that answer. What about the other answer? Well, let's check with x equal to -1/2. Now, it's harder to work with, it's going to be fractions with fractions. So let's write this as a decimal. 1/2 is the same as 0.5. So this is going to be -0.5. What happens when I substitute that in? I'll get 1 plus -0.5 over -0.5 minus 1 over 1 over -0.5 squared minus -0.5. And I'm going to use my calculator to work this out. This will stay 1. This will be 0.5. Okay, so first I want to do on my calculator, I'm doing this in steps, negative 0.5 minus 1. Which is negative 1.5. And that's 1 over, well, now I'm going to put that over parentheses, negative 0.5, close parentheses, squared, minus negative 0.5. I'm putting it into my calculator exactly the way I see it, which gives me 0.75. And now I'm going to actually work this out. I'm going to first do the negative 0.5 divided by the negative 1.5, which gives me 0.3333. I'll go to 4 decimal places, so that's 1.3333. And on this other side, I'm going to do 1 divided by, remember, fraction is a division, 0.75. And that also gives me 1.3333. So this actually checked. This answer is a good answer. And therefore, when I give my solution, I don't give both of these. My solution is just the x equals negative a half. I do not include, even though it came out as an answer, don't say negative 1 because it's extraneous. It's no good. It has to be thrown out. There is only one answer to this question, and that is negative a half. Okay, now, if you notice, I think this took us 15 minutes to do. These problems are probably the most, I don't know if they're the hardest, but certainly the ones that take the most time. They're very time consuming, and it's so easy to make an error when you don't have when you're working something that's so long. So here's what I suggest you do. When we got over here, after we factored, we had 1 over 1 plus x over x minus 1 equals 1 over x squared minus that. I'm sorry, let me get factor this. Over x times x minus 1. Before I do any work on it, I'm going to look at what answers will not be allowed. What answers will give me extraneous roots? And the answers that will give me extraneous roots are those that will make any one of the denominators equal to 0. So let's look at our denominators, the bottoms. This is a plain 1. Nothing is going to make that equal to 0. The next denominator is x minus 1. Let's see what will make x minus 1 equal to 0. If I set the denominator equal to 0, that'll give me x equal to 1. I know that if my answer comes out to be x equal to 1, I've got to scrap it. I could have known that right before, as soon as this came out. As soon as I saw that one of my answers is 1, I could right away say that could not be an answer. The other thing that we can is, what if this denominator turns out to be 0? If x times x minus 1 is, what will make that equal to 0? Either the x equal to 0, because it's already factored, or the x minus 1 equal to 0. And this again is x equal to 1. Well, we know that already. In other words, there are just two answers that we would never be allowed, two answers that if they come out as answers are extraneous. If you're looking at a multiple choice problem, especially, if you do this right up front and it gives you one of the answers, including either a 0 and a 1, you know those answers are no good. You right away can eliminate some of your answers. So if you do a little bit of the work up front, then when you get over here and you come out with your two answers being 1 and -0.5, you know right away. And if you don't have time to check anything else, you assume that you've done your work correctly. If you've done your work correctly, then the -0.5 has to be, and that's the harder one to check. If you don't check it, just assume that that's your right answer. But again, if you want to save time and you feel very uncomfortable with these, what you can do is you can first figure out what your extraneous roots would be, and if they come out as an answer right away, eliminate it. Okay. This takes care of solving rational equations. We're still finishing up chapter 5. I want to do one more topic on chapter 5, but before I do that, I'm going to ask, does anybody want to ask me about anything that is on the midterm?
It's not about the midterm, but I came late. I'm here. I don't know if you took attendance.
Oh, yeah, I saw you, but you sent me a chat, right?
I'm sorry, what?
Did you send me a chat? Who is that? Sosa?
Yeah, this is
Yeah,
me.
I saw. I'm gonna change my attendance. Okay.
Okay. Mhm. Also, when is the midterm?
Okay. I I wish you would look at your emails because I keep sending you emails. You have starting this afternoon from 2 o'clock until Thursday, 10 o'clock, you can do this midterm. If there's some reason that you could, if there's some reason you cannot do it in that time span, you have to be able to allow yourself an hour and 15 minutes. That's the amount of time. Don't think that you're going to go and start it and then stop it in the middle and eat your lunch and then come back. Your time will run out. Once you start it, you have an hour and a quarter, and then it will automatically submit. A few people, I hope most of you have learned from the mistakes that you made on that practice midterm so that there won't be these false submissions. Don't submit the final thing until you're sure you're ready to submit it. But if you go over the hour and a quarter, it's going to automatically submit. Okay, so somebody asked me if I could do a word problem of the type that might be on the midterm, and I would gladly do that. Okay, thank you, Farhas, for doing that for everything. Okay. I'm just looking for a problem that will be appropriate. So here is the type that you might see on the midterm. Tickets to a local movie sold at $10 for general admission and $6 for seniors. So we have two types of tickets to this movie. 190 tickets were sold. And for a total of $1,740. How many general admission were sold? And since this is a multiple choice question, I'm going to give you the choices and I'm going to give you a few minutes to try it. Choice A is 40, choice B is 150, choice C is 30, and choice D is 109. Okay, I'm going to give you a few minutes to try this on your own, and then we're going to work it together. You might see something of this nature on the midterm. Is that what you were asking me for? Perhaps, would that be? Yeah, okay. Okay, so I'm giving you a few minutes to try this. Okay, I think we should start trying together now. We have two things that we don't know. We don't know how many general admission tickets were sold, and we don't know how many senior tickets were sold. Now, let's decide on our variables. Remember, this is what's called making a legend. Should we call them G and S? Let G be the number of general admission tickets, and let S be the number of senior tickets that were sold. Okay, we have two things we don't know. We have two variables, we need two equations. What should our first equation be? Well, I see the first bit of information they gave me is that 190 tickets were sold. That means the number of general admission tickets together with, plus, that means the senior tickets has to be equal to 190. So G plus S has to equal 190. Notice it has nothing to do with how much the tickets sold for. It's just how many there were. So we don't include the $10 and the $6. Doesn't matter what they were sold for. It's just how many were sold. Our second bit of information told us that how much money altogether it sold for. Now we have to include not only how many, but the price. So for the next equation, we do 10G, that's $10 times the number of general admission tickets sold, plus 6S, that's how much they got from the senior tickets. That totally is going to give me $1,740. I hope most of you got that equation. Okay, we now have a system of equations, so we now have to solve it. And specifically, we were asked to figure out what the G is. Okay, so that means let's get rid of the S. Now, if I figured out what the S is, I could still figure out what the G is, but since they specifically asked me for the general admission, let's work it efficiently and get rid of the G. In order to get rid of the G, I'm going to have to multiply this by, I'll multiply this by -10 and this one by 1. Because we multiply by the opposite coefficients And since they're both positive, one of these numbers has to be negative and one has to be positive. So my top equation becomes negative 10g minus 10s equals negative 10 times 190, which is negative 1,900. And the bottom equation, if we're just multiplying by 1, stays 10g plus 6s equals, oh, I'm sorry. I told you the wrong thing. I really should have gotten rid of the s's because I want to figure out what the g's are. I'll do it this way and then I'll go back since I already started this. This is 1740. So here the 10g and the negative 10g cancel out. Negative 10s plus 6s is negative 4s. And negative, this I'm going to take my calculator. Negative 1900 plus 1740 gives me negative 160. And if I divide by negative 4, I get that S equals 40. Now, here, this is the advantage of using not just X and Y, but G and S. S, I know, obviously stands for senior. And the question was how many general admission tickets. This is where you could get stuck on a multiple choice. 40 is not the right answer because 40 is how many senior tickets. If I want to find the general admission tickets, I'm going to go back to this equation. G plus S equals 190. I know the S turned out to be 40, so G plus 40 equals 190. And G equals 150. The number of general admission tickets is 150, which is choice B. So don't make the mistake. I really should have over here, instead of getting rid of the G's, I should have thought, oh, I want the G, so I get rid of the S's. I said it and I did the opposite. But in either case, it doesn't matter if I figured out what the S is, as long as I concentrate on what I'm looking for and I answer the question that's being asked. Okay, I see. Yeah, great. And this help. Okay, great. I'm glad this was a help. Okay. I think those are the only type of word problems that you have to worry about on the midterm. When it'll come to the final exam, there'll be some others and we'll review those later in the term. Okay, here's what I'd like to do now. I'd like to start the last topic in chapter 5. When we started chapter 4, we learned to do actually 4 things in chapter 4. It was chapter on polynomials, and we talked about, well, adding, subtracting, multiplying, those 3 things. And the 4th thing we did was factoring. And once we did factoring, then we talked about solving quadratic equations using factoring. But what we never did in that chapter is dividing. We never talked about what happens when you want to divide polynomials. And we talked about dividing monomials, but we didn't talk about dividing polynomials. So that's what I'd like to start today. I don't know if I'm going to be able to complete it. That is the last topics in chapter 5. So this can be broken up into two different types. One is when you divide a polynomial by a monomial. In other words, multiple terms in your numerator, a single term in your denominator. This is, I'm looking at example number 613 on the sheet 5 examples. Suppose I gave you something like this. 15 a to the third b plus 30 a squared b squared plus 20 a b to the third. So we have a trinomial here that we want to divide, and it specifically says divide. Doesn't say reduce, it says divide. Even though we're writing as a fraction, it is a division problem. We want to divide it by 15 a squared b squared. We are taking, in this case, a trinomial and dividing it by a monomial. And the way we do something like that is very interesting. What we do is we take our polynomial and break it up and divide each term of the polynomial by the monomial. In other words, we rewrite this as 15 a third b over 15a squared b squared plus 30 a squared b squared over 15 a squared b squared plus 20 a b third over 15 a squared b squared. When you're dividing a polynomial by a monomial, you're dividing every term of the polynomial by that monomial. So let's separate it. And what we end up with is 3 different problems. We reduce each of these fractions as much as we can, and that gives us our answer. Now let's remember, when we're reducing a fraction that's with monomials, we look at each part separately. So we first take the coefficients, which are 15 and 15. We can just cancel them out. Then we look at each of the variables. First, the a's. There's an a to the third over an a squared. Remember what we did before. We've done this before. We cross out or cancel out the one with the lower exponent and subtract that exponent from the higher. So 3 minus 2 is 1. And we get a to the 1, which is just a plain a. Remember that the answer, or the letter, remains where the higher exponent is. The next thing we have are b's. So I have a b over a b squared. The one with the lower exponent is the b. So I cross it out. Its exponent is 1, and 2 minus 1 is 1. So this just gives me plain b. So my first term turns out to be a over b. I just reduced that. Remember, if everything cancels out from either the numerator or the denominator, what's left there is a 1. You're canceling out with division. Okay, I then go to the second one. There's a 15 and a 30. 15 goes into both of them, so I cancel out the 15. The 30 divided by 15 gives me 2. Then I look at the literal parts, the variables. There's an a squared at top and an a squared on the bottom. They're the same exponent, so they just cancel out. And the b is the same thing. The b squared cancels out with the b squared. Notice I'm left with a 2 on the top. What am I left with on the bottom? Which is a 2. which is just 2 over 1. Don't forget, if something totally cancels out, there's a 1 left there. Finally, we go to our last term. Between 20 and 15, we can cancel out a 5. 20 divided by 5 is 4. 15 divided by 5 is 3. The a and the a squared, the lower one is the a. 2 minus 1 is 1, so I'm left with an a in the denominator. And the b third and the b squared, the lower one is the b squared. And 3 minus 2 is 1, so it's b to the 1, or b. So my last term comes out to be 4b in the numerator over 3a. Now, this 2 over 1, you could have written also as just plain 2, and then you could write your answer a over b plus 2 plus 4b over 3a. In other words, since we had 3 terms, we had a trinomial that we were dividing, we ended up with 3 fractions in my answer. This is the answer that you get when you divide a polynomial by a monomial. Okay, I'm going to give you one to try. Okay, so look, I want you to try this one. Putting it over here. Suppose I give you 12x to the 5th minus 18x to the 4th minus 6x squared, x to the 3rd, I'm sorry, divided by, this is again a division, 6x to the 3rd. And again, it'll either say divide or it'll say find the quotient. When you see the word quotient, it means that you're doing a division. And when you do a division of a polynomial by a monomial, you do it the method I just showed you before. No problem. I'll finish before 11:30. Okay, I think there was enough time here. Let's see if we can work this out. What I'm going to do is I'm going to first erase this. You might have needed it to look at, but now I think it's just making it look too messy. Again, the question we have here is how do we divide a polynomial? In this case, it again is a trinomial. It's 12x to the 5th minus 18x to the 4th minus 6x to the 3rd over 6x to the 3rd. And again, remember what we said. Again, if it says find the quotient or if it says divide, you take each term from your polynomial and separate it and put it on top of that monomial. In other words, you do 12x to the 5th over 6x cubed minus 18x to the 4th over 6x to the 3rd minus 6x to the 3rd over 6x to the 3rd. Even though it looks like a lot of extra work to rewrite this way, it means that you can work with each one of these fractions separately. Okay, looking at the first one, I have a 12 on top and a 6 on the bottom as coefficient. Obviously, 6 goes into both of them. 12 divided by 6 is 2. The 6 cancels out. X fifth and x third, the lower exponent is the x to the 3rd. And if I do 5 minus 3, it gives me 2. So on the bottom, I'm left with 1. So my final answer for that first fraction is 2x squared over 1, which you could write as just plain 2x squared. Anytime your denominator turns out to be 1, you don't have to write that in. Okay, going to the second fraction, we have an 18 and a 6. The 6 goes into both of them. 18 divided by 6 is 3. The 6 cancels out. Then we have an x4 divided by an x3. The lower exponent is the 3rd. Remember, you're always taking the lower one and canceling it out and subtracting that number from the top. Sometimes your x's end up being in the bottom rather than on the top. It doesn't matter. In this case, the higher one is a 4. 4 minus 3 is 1. So we're left again with a 3x on the top and a 1 on the bottom. That's minus 3x over 1, which I could just write as 3x. And finally, here both the x's cancels out and the x thirds cancel out. Now everything canceled out. Remember, when everything cancels out, you put a 1. So this becomes minus 1 over 1, which is minus 1. And your final answer turns out to be 2x squared minus 3x minus 1. And yes, that was correct, Nikisha. So that's how you would divide a polynomial by a monomial. Now, we still have to learn how to divide a polynomial by a polynomial, but that takes a little bit more time than this, and we only have 15 minutes left of class. I don't see a point of starting it when I can't get through the whole lesson. So the first thing I'm going to do when I get to class on Thursday is I'm going to start with dividing polynomials by polynomials after we do a little bit of review. Again, I'll be available for questions, and